Hello everybody. This video is going to take us through LeetCode problem 101, which is symmetric tree. So given the root of a binary tree, check whether it is a mirror of itself, symmetric around its center. So if we look at example 1 here, we see that it is symmetric. 1, 2, 3 is the same as 1, 2, 3 with the 4s in the center. Example 2 is not. You have a root here which is 1, 2, 2, and then it's a null because there's no left branch, and then the 3, another null for no left branch, and then the 3. You can just see drawing the line down the middle that those are not symmetric. Alright, so we're going to use recursion with this one. When comparing trees, comparing values, one value to another. Recursion is usually a good option. So this one's a little bit different. We're going to start with the isSymmetric method, and we're going to pass in the root, the tree node root. Now we're actually going to call another method, because what we need to do is we need to take this tree and compare it against itself so that we can basically, it will be like it's a mirror image. So we need to duplicate it. So we're going to call just another function that's going to pass in the same tree. And so we'll do that, and we'll call that isMirror. We'll pass in T1 and T2, which these are the same trees. So the first thing we'll do is if T1 equals null and T2 equals null, we're just going to return true. If T1 is null or T2, so not both of them, one or the other, then you can return false, because obviously they are not identical. Otherwise, we need to check that the T1 value is equal to the T2 value, and because we're looking for mirror images, we're going to compare T1 left, so the left side of the tree, with T2 right, so we're going down the right side of the tree. And we also need to compare the T1 right, so the inner branch, with T2 left, so the branch over here. And that is pretty much it. Now, debugging recursion can be hairy, so I'll try and make it as simple, explain it as well as I can. So the first time through, we passed in, so I just took a simple tree. The root is 1, we've got 2 on the left and 2 on the right. So neither one of them are null. Okay, so this is gonna, so T1 is equal to T2, they're both value 1. So now we're going to call isMirror again with T1 being 2 and the T2 left, which is also 2. And then we're also going to call isMirror again, passing T1 left and T2 right. Okay, so the first thing it's going to do is it's going to deal with this side first, this isMirror. So this is going through, and the 2 is equal to the 2, but it calls isMirror twice again. So you can see where this can get really big really fast. So because there's no values in the right or the left, the left 2 branch doesn't have any sub branches. So that's null, and we have another null for the isMirror from the first 2 on the left side. All right, so now we're going to go back and deal with the isMirror from the 2 on the right side of the tree. And that is 2 equals 2, but again it calls isMirror twice again with null values. And because T1 is null and T2 is null, it immediately goes to the return statement. So we do it one more time, call in the nulls, and then it will exit out and return the result true. And you can see now why it did such a small one. Otherwise, it multiplies. We did that. That was 7 iterations of isMirror. And if we did another level, 8, 9, 10, 11, 12, it'd be like 15 iterations. So I didn't want to bore you with all those iterations. All right, let's run it through LeetCode. Run this code, accepted, and submit. What? 31%. Sometimes you run this. There, see, now it's 100%. Faster than 80%. I don't know how accurate this is. Go from 31% to 100%. Okay, and then finally, let's go through the time and space complexity. So time is O of n. It depends on the size of the tree. And space complexity is also O of n. More tree means more space. Okay, another fun recursion problem. Hope you learned something, and we will see you next time. Thanks for watching.